Determine if two statements are equivalent using De Morgan's laws. Okay, so two statements equivalent, if we're thinking in terms of truth tables, that would mean they would have the exact same column in a truth table. That means equivalence. Well, sometimes we don't want to make an entire truth table, so we can use De Morgan's laws. There are two of them. So before we get into this, let's review what are De Morgan's laws. Well, the first one, right, knowing that both of these deal with negations and distributing those negations over a statement. So if I have the negation of the statement P and Q, the biconditional, meaning the left side and the right side are equivalent, would be not P or not Q. So you'll notice how we basically distributed the negation and flipped the sign. So that's the idea of De Morgan's laws. Well, that applies to the first one. The second one, let's just change P and Q to P or Q. Let's make that a disjunction. Then we have our biconditional. So if you think about the idea of distribute the negation and flip the sign. So instead of or, we have and. So these are the two ideas of De Morgan's laws, to create equivalent statements based on negation and distributing negation. Okay, let's do some examples real quick. So first, let's just fill in the blank. Fill in the blank is always a fun one. To make the two statements equivalent based on De Morgan's laws. So notice what we have. On the left, we have not P, some unknown Q, if and only if not P and blank. Now think about what De Morgan laws do. First, they distribute the negation. So that means I know this on the right side has to be not Q because we distribute the negation and we flip the sign. So if the sign on the right is and, that means the sign inside must be or. So we know that not P or Q if and only if not P and not Q, based on De Morgan's law. Second one, give an equivalent statement based on De Morgan's laws. I don't like olives or bananas. Okay, well, let's think about this first of all. Let's just say that P is I like olives. Gross. Let's let Q be I like bananas. Bigger gross. I'd rather throw up in my mouth every day than eat bananas. Gross. Okay, so I like olives, I like bananas. This, I don't like olives or bananas, means not olives or bananas. I don't like either of those, right? I don't like, there's the not, olives or bananas. So what would be the equivalent? Well, not P and not Q. So in words, I don't like olives. Oh, got the wrong word there. I don't like olives and I don't like bananas. Those are true. And if you look at them, you're like, well, yeah, I don't like olives or bananas is the same as I don't like olives and I don't like bananas. Logically, that makes sense in our head because they're equivalent. Let's just do one more real quick. You're given not P or not Q. What is an equivalent statement? Well, a lot of times we've been writing that on the right? The distribution of the negation. So let's think back. Well, if we undistribute, so let's take the negation out of P and Q. And remember, the other piece is we flip the sign. So if it's an or on the right, it's an and on the left. So not P and Q, if and only if, not P or not Q. And that right there is playing with equivalencies with De Morgan's laws.